Okay, guys, looking at the review packet for Summative 3. Number, I don't know why it's out of order. I think I forgot to renumber them, so 3A. Now, first of all, can you guys please recognize that this section was on your last summative? You're going to get a new score, so please do better, or if you had a 5, get a 5 again. So function f is that guy, and function g is this one. So when it says f of -2 plus g of -2, I think the easiest way to do that question is to plug in -2 into each function and then add them up. So has someone already taken care of this? What happens when you plug in a -2 into function f? And please use parentheses when you do this. 45. I heard 45. Can I get a confirmation on that?
Yes, it is.
Thank you. And then same thing here with function g. You're going to plug in a -2 right here. -16?
No, there's... I don't even know what it is.
Are you on the different question?
It doesn't seem like that, like...
7 times -2 minus 2. Is that -16?
Yes.
Don't just say yes, is it?
Yes. Yes.
All right.
16.
I'm trusting you all.
Yes, Mr. Russo.
Then you're adding these together. What'd you get? I feel like this is not the answer I got last hour. Is something wrong?
They did it wrong.
Maybe. I don't know. Okay. All right, so this is the correct answer. You guys did get 29. Now, on your last summative, some of you really forgot something very important on the next question when it says f minus g. Some of you set it up like so. And then you forgot to do something. What's wrong with setting it up like this? Parentheses. Yes, you have to subtract the entire function g. So the -7x, but this will become a +2 on the end. So final answer of 8x squared minus 12x plus 5. So they didn't give you anything to plug in for the x into the functions. That's why we're getting an algebra answer. Next question here, very similar to the first part, except this time when I plug in a 2 to each function, we're going to be multiplying our answers together. On the last test, some of you guys tried to multiply the algebra, all the components together. That's not a great way to do the question. Just plug in a 2 to f, plug in a 2 to g, multiply your numbers together. So a little bit of calculator assistance from some people. If I plug in a 2 into function f, you get a what? 32. Okay. And if you plug in a 2 to function g, I'm thinking that's 12.
Yeah, it does.
Is this 32 though? This isn't right. Can you guys, someone plug in a 2 into function f, please?
25.
25? Okay, and what's 25 times 12?
300.
300. That's the answer I'm looking for. You figured out where you're getting these answers from? Okay, we'll come back and look at that. All right, f divided by g. The setup for f divided by g should be the easiest question on this whole test. You just say 8x squared minus 5x plus 3 over 7x minus 2. Now, on the last summative, some of you left this part blank. I need to know the one value that x cannot be. So I can't divide by 0. So what you're going to do is you're going to take your denominator, which is 7x minus 2, and you're going to off to the side tell me that it cannot equal 0, and then I need you to solve for x. So we're going to add the 2, divide by 7. You're going to get x can't be 2 7ths. Okay. 2 7ths. 2 7ths. X cannot equal. And then I'm a little close on space here, but on the last summative, I'm not quite sure what happened. I don't know if people just didn't see this question, but a lot of you left it blank. So f of g of 2. This is composition. You have to start on the inside of composition where you figure out g of 2, which I think we already figured that out a couple problems ago. Wasn't g of 2 12? So now it says take that 12, plug it into function f. So plugging in a 12 here is quite a large number, 1095.
See, when I get an answer like that,
Well, when you're plugging into like a larger order polynomial, they get pretty big. So don't be afraid if you get something in the hundreds or thousands.
yeah, see, when I get like 3,367, I'm like, I think I missed something.
It happens. All right, so I'm going to leave 3B for you to do on your own. Guys, if I could encourage you to, beyond the class time here, do 3B on your own. Because you guys are getting a rescore on this, and I feel like that was a really weak section on the last summative. All right, advanced factoring. This is another section where you're getting a new score. And I hate to break the news to you, but I did make this section more complicated than the last test. I upped the rigor, as we say. So, 4A. There's no common factor here, and it's two terms. So following my factoring flowchart, I'm going to recognize that this is the sum of two cubes pattern. So I'm going to write down a plus b, a squared minus ab plus b squared. So on the last summative, when we had the cubic pattern, some of you guys had issues with so on the last summative, when you used the cubic pattern, some of you forgot to do that very important step of actually cube rooting the pieces here. So going backwards, the cube root of 27x to the third is a 3x. And the cube root of 8 is a 2. So that's what we're going to place into the cubic pattern. So a plus b is 3x plus 2. And then a squared, this is where I'm a little worried about some of you because we haven't done one of these on a test yet. A squared would be like 3x times another 3x. What is that? Be 9x squared, right? Minus a times b would be 6x plus b squared, which is 4. So that's the cubic pattern. You don't factor further on cubic patterns ever. When we look at number 5A, so back to the top of the flowchart. The top of the flowchart says take out any common factors. So 5A does have a common factor of 6x.
Is that our answer?
Yep. And then if you remove a 6x from this expression, you still have x to the fourth minus 1. Now, if you think we're done, you clearly don't know your teacher that well. There's no way I'd give you one that easy on a test. So x to the fourth minus 1, that's a binomial, so it's one of our patterns. Are those cubic or squared numbers? I mean, I know 1 is both cubic and squared, but well, think about x to the fourth. Is that something you can square root easily?
Yeah.
Yeah. So it's the difference of squares pattern. So the 6x stays in front, and we're going to use the good twin, evil twin pattern here. So twin factors for x to the fourth are x squared. And then it's a plus 1 and a minus 1. And you think we're done?
No.
You're right, we're still not done. This is what I mean by I upped the rigor. Look at this guy. X squared minus 1 is another set of twin factors. How do you factor x squared minus 1? X and x. And then a plus 1 and a minus 1. So everything else stayed as it was. Still a 6x, still an x squared plus 1. And then that is the full factorization. So I'm really worried about that question because that's much more elaborate than the last test. So please, please, please practice 5B on your own. It's a very similar question. All right, and then 6A and B are all factored by grouping. So first group versus second group. So common factor in our first group here is a 3x squared. So taking out a 3x squared, you still have x plus 2. And then we need the parentheses to match. So the common factor for the second group is not just a 5, but let's take out a negative 5. So if I divide both of these by negative 5, I get an x plus 2. Now, on the last test, some of you stopped here, and I had to write a note like, keep going. You weren't done. You still have an x plus 2 factor to take out. And when you remove an x plus 2, so these guys are gone, you still have 3x squared minus 5. Then you're done. Okay? So 6b is very similar to that. If you know that you kept messing up factor by grouping, try it again. So that was another section where you're getting another score. Please, please, please do the best you can because I don't intend to retest this anytime soon. Oh, and inverses. That was the third one that we're going to see again. So inverse functions. Some of you left this blank on the last test. So I don't know what happened there, but f of x is really just a y. The first step in inverse functions is to switch the x and y. So if I switch around the x and y here, that gives us x equals 8y minus 5. And then this function notation is what you're going to have once you solve for y. So let's add the 5 over. So we have x plus 5 equals 8y. And then what's my last algebra step to get y by itself here? Still going to divide by 8. Now, I don't mind that some of you did like you wrote down x plus 5, all of it divided by 8 like this. I'm okay with that answer, but the best answer is this simplified. So 1/8 x plus 5/8. Okay, so that's the best answer. And then I'm going to switch up the way the question is asked from last test. Last test we had that question where you had to like check how many were true in the bubble section. This test is a little different. So you have to really understand the concepts that revolve around inverses. So like for instance, domain and range. What happens to domain and range for inverse functions? They are not the same necessarily because they reverse or they switch. So switch is a good word to use, or reverse. And then the sometimes always never question, a function and its inverse are the same. That's not usually true, but it can be true. There were functions that have the same inverse, so that's a sometimes. And then can you have a function whose inverse is not a function? Yeah. That's because the original would have failed the horizontal line test. And then the line that reflects inverses and originals on the coordinate plane is the line y equals x. These are all things I just pulled straight off of our notes. In the top of 6.7's notes, there's a box of properties. All right. Pay very careful attention to these questions, guys. I'm going to ask you to provide me a picture of either a function whose inverse is a function or is not a function, and then you're going to have to explain to me why that's true. So, give an example of an original function who also has an inverse who's a function. So you need to draw me something that passes the vertical and the horizontal line test. So like this guy right there passes the horizontal and the vertical line test. So that would work. But if I asked you for an example of an original function whose inverse is not a function, then you need to show me something that passes the vertical line test because I need him to be a function, but I need him to fail the horizontal line test. So how about your friend the parabola? That would fail the horizontal line test, right? So if I ask you for an explanation as to why this has an inverse that is not a function, the explanation has to be real specific. You have to say that the original function fails the horizontal line test is what I'm trying to write. Well, the original, if it fails the horizontal line test, that means the inverse is not a function. Okay? Yep. So I keep getting kids who write explanations like fails horizontal line test. That's not an okay answer. You have to tell me who fails the horizontal line test. The original fails the horizontal line test. So this parabola would be considered the original function. Yep. What's happening? Hope it's actually recording. All right, guys. Oh, I took a screenshot of my own screen. That's weird. All right, guys, long division. So as promised, I'm going to give you smaller polynomials to perform long division on. So I've helped a lot of people like in tutoring for long division over the last few days. And what we've decided is using a little bit of color is going to make a big difference because this can get challenging. So we're going to set up our long division question. I'm going to move this over though so I have space. So 3v squared minus 31v plus 67 is being divided by, and I always like when you use parentheses here, v minus 7. So if you only are going to use one color, the point in your work that I'd like you to use a color is when we do the subtraction. So for me, I use lots of colors because I like to use colors. So 3v squared divided by v. Off to the side, I could write down 3v squared divided by v, and that reduces to a 3v. So answers to the division problems go up here. This is where my answer is going to be. And then I multiply 3v times the divisor, 3v squared, but you got to distribute here too. So those of us who feel like this is where we're messing up, literally write out 3v squared minus, or sorry, 3v times v minus 7, and then show me the distribution off to the side here. So 3v squared minus 21v. So this is the moment where if you only have one color, this is where I'd like you to use it. I want you to use a pen to put parentheses right here, a subtraction sign outside, and then like a fraction bar to break up your work. So if you have one color besides the pencil, that's where I want you to use it. So lead term cancels, and this is where I would also expect you, if this is where you mess up, grab a calculator and type in the integers. Negative 31 minus negative 21. Ah, type that. Negative 10v. And then bringing down the next term, now we start all over again. The negative. Yeah. Negative 31 minus negative 21, is that what you're asking about? Yep. Oh, the next step is we're going to divide. So negative 10v being divided by v reduces to negative 10. Nope, just v, or negative 10, sorry. So now we're going to distribute negative 10 times v minus 7 gives us negative 10v plus 70. And then again, if I only have one color to use, this is where I use it, right here. I'm going to subtract. So my lead terms cancel, and then again, if this is where you mess up, please check on your calculator. 67 minus 70 is negative 3. So my answer, which on your test it'll have a blank off to the side that says quotient, you're going to have to rewrite your answer over there. So you guys would write 3v minus 10, and then the remainder is written as a fraction where it's still being divided by the divisor. There we go. So one more concept we got to talk about, and that's synthetic division. So setting up synthetic division, in the little half box, it's the solution to your divisor. So the solution to this divisor would be positive 6. And then I want you guys to look really carefully at this polynomial right here. It's missing some terms. Yeah, we're thinking it's missing a cubic term. So this is really like k to the 4th plus no k to the 3rds minus 36k squared plus 8k. Oh boy, minus 48. So if you have a hard time figuring out where the zeros belong, I suggest you expand it out to full standard form. So now when I set up my lead coefficients, I start off with a 1, and then thank you for pointing out we have a 0, negative 36, 8, and negative 48. So to get synthetic division started, you got to bring down your lead term. And then it's a series of multiplications and additions. So if the number is below the line, that means we're going to multiply it. So 1 times 6 is 6. And then we're adding them up, and we're getting 6. And then 6 times 6 is 36. And when we add that column up, we get 0. And then 0 times 6 is 0. Careful, everyone messes that one up. And then 8 plus 0 is 8.
Why'd you put a 0?
Because there was a cubic term that was missing, and it has to go in decreasing order all the way down, hitting every single term. Let's see, where are we at? Oh, 8 times 6 is 48. So this is a case where we don't have any remainder, which is great, but we don't actually have the quotient yet. All we have is the coefficient. So if I look at my original problem, I took a k to the 4th power and I divided by a k to the 1st power. So my leading term of my answer is going to be a k to the third power. So this is k to the third plus 6k squared. Someone in a previous class said, do you mind if I write plus 0k? Because they kept forgetting it. I said, it's fine. And then plus 8. So just to be clear, you guys don't have to have the 0k part. You can just have that. 2 steps in the process. Yeah, multiply, add. Yeah. So as far as math goes, it's easier. The setting up and the translating the answer is kind of weird. Yeah. They both have their positives and negatives, both methods. Can we look at number 13 real quick? So, is 13 missing any terms? That would be my first question. It goes quadratic, linear. Okay, so it's not missing any terms. So in the solution to this divisor is positive 8. Good. And the coefficients are 3, negative 19, and negative 43. We will, but first we got to drag that term down to get it started. So now we multiply. Yep. And then we add them up, and we get 5. And then we multiply again, and that's a 40. And then we add them up, and we get negative 3. Now remember, this last number you get is your remainder. So if I think about what we started with, guys, you started with a quadratic, a 3x squared, and you divided by an x. So your leading term should be what? 3x. So this 3 is really 3x plus 5. And then same thing with the remainder. So I know synthetic division seems like really, I don't want to use the word easy. Seems simple, right? There's a lot of stuff in synthetic division. Like you have to know how to set it up. You have to know about zero placeholders. You have to know how to write your answer when you're done. You have to know about remainders. So there are a lot of concepts within it, so be careful. All right, that's your summative tomorrow.